Welcome to qnawire.
Okay, so we're being asked to state the first and second derivative test. Okay, so the first derivative test tells us that if f prime is changes from negative, I'm sorry, let's start with the positive. If f prime changes from positive to negative at a point C, then f has a local max, has local sorry about that, local max at C. And this makes sense because if you think about it, when a graph is increasing, so it's going up, 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 and then suddenly it goes down. You can see that at this point, when it changes, it has a local max because it is greater than all the points in the neighborhood. So that's why this is very important. So that's kind of important to understand visually. So that's the first point. The second point is if f prime is the other way, so it goes from negative to positive on an interval, and it occurs at point C, then f has a local min, at C. And this makes sense because when you go negative, 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 positive, positive, the local occurs because this is the lowest point in the neighborhood of this, or its surrounding point. And then if f prime does not change, so there's no change, then there is no local max. So then there is no local max or min. And the reason why this is true is because if you're increasing, you don't know if this point is the local max because we don't know if it's going up or down, up or down. It's just going to keep going up, and it could be a global max. It could be not. We're not sure. It all depends. So when we know there's no change, we know for a fact there's no local max or local min. And then for the second derivative test, we take the second derivative, which is part of the name. So if f prime of x is greater than 0 on an interval I, so on an interval I, then f is, I'm sorry about that. Let's make that I more. Then on an interval I, then f is concave up, so concave up. So that will be the shape of the graph. And this is the second derivative test is very helpful in helping us understand the shape of the graph. And then if it's less than 0, so the second derivative is less than 0 on the interval I, then it is the opposite, which is concave down. And concave down looks like this, like an upside down U. So concave down. And then the last part of the question asks us, under what circumstances is it inconclusive? And what do you do if it fails? Well, it is inconclusive when f prime of x is equal to 0. We don't know if it's in concave up or concave down. And then, so then what we do is we refer to the first derivative test, because the first derivative test will always tell us what's happening. The first derivative test. And if you think about it, you really don't even need the second derivative test, because the first derivative test will tell you that the function is decreasing on this, like let's do it like this. So decreasing because this is where it's decreasing, and this is where it's decreasing. And then if it's increasing, the first derivative tells you that this is increasing and this is increasing. So the second derivative test there is there to help us visualize what's going on. And make it a lot easier to draw the picture, but you technically don't even need it. And that's why the first derivative test is so important. So if you really only need the first derivative test. All right.